Alrighty guys, we are going to add some more logarithmic properties in today. So I'm right across from the one we did in the last video, so on page 93. And I have 3 additional properties for you. Two are pretty handy for solving purposes, which we're going to get into next time. And one is a thing that we need to know because TI-83 calculators or TI-82 calculators or whatever TI calculator you're using doesn't always have a way for me to evaluate logarithms, which is super annoying. We'll get to that. So I have 3 new properties for you today. First one, like I said, these are going to help us to begin solving with a logarithm, which we'll do next time. So my first new property is called the inverse property, which thinking about an inverse property in terms of solving should hopefully make a lot of sense. Like we need to know how to do the inverse. Okay, so our inverse property looks like this. We can have log base b of b to the m power. And when the log base matches the exponent base, they just kind of go away. And your answer is just m, or you just equal m. Like if these two match here, they just kind of disappear. Then the reason for that is like your m can boop out front using that product property or the power property, boop. And then log base b of b is just 1. So if it's log base 5 of 5, that's 1. Log base 2 of 2, that's 1. So 1 times anything is just that thing. So that's kind of why that works. And so an example of that is if we have log base 2 of 2 to the 7th, like don't do 2 to the 7th, that seems like a bad time. This is just going to equal 7. Like the log base 2, just cancel out to 1, and then you're just 7. Now this kind of works in the reverse order as well. So if I have an exponent with a base of b, and then it has a power with a log base b of some number, then again, because the base of the exponent and the base of the logarithm match, they just kind of go away, and you're left with the exponent. Or I'm sorry, in this case, you're left with the thing you're taking the logarithm of. And so 2 quick examples like that, like kind of a simple one, could be something like 7 to the log base 7, 10, like this. And so because the base and the log base match, they just go away and you're 10. But maybe a slightly trickier one, for example, could be something like this, where you have to maybe do a little bit of clever math manipulation. Is if I had 3 to the 2 log base 3 of x. Well, first, because the base and the log base aren't like butted up with each other, I have to rewrite this a little bit. Like I have to take my 2 and boop it back. So we're looking at 3 log base 3 of x squared. And then my base and my log base are right up next to each other. So they go away, and you're just left with x squared. So somewhat of a trickier one, but hopefully not too bad. We're just looking for those matchers. Okay. Another property that we have that can be super helpful in solving, and we're going to just straight up solve on these ones, which is kind of nice, is called the one-to-one property. So the one-to-one property, it basically says if I have 1 logarithm equal to 1 logarithm and nothing else, then I can kind of just ignore the logarithms and solve for what's inside. Or with exponentials. So for example, let's do like a little 2-column thing here. If I have log base b of x equals log base b of y, then I should just know that x is equal to y. So because I have one logarithm equal to one logarithm, and they're the same, the stuff inside should be the same. So an example of that would be something like if I had the natural log of 2x minus 3 equals the natural log of 3x minus 8. Because I have one logarithm equal to one logarithm, the stuff on the inside should just be the same. So 2x minus 3 has to be the same as 3x minus 8, and then we just solve from there. So like subtract the 2x, add the 8. So x is 5. Boom, you're done. Easy. No sneaky stuff. Now the other way this works is with an exponent. So if I had a number to some power equals the same number to some other power, again, if the base numbers are the same, then their exponents would also have to be the same. So x would have to equal y. Now again, we can kind of do some fancy stuff with this one, which is easier with an exponent than it is with a logarithm. So I'm going to try to show you a little bit of a more complicated one here. So if I had 5 to the 3x plus 1 equals 25 to the x minus 4, looking at them right now, I don't have the same base. And I can't make 5 not 5. So like I can't just square this for funsies, because if I square one side, I have to square the other. And I can't just make 25 5, because I'd have to like square root this side, and if I square root this side, I have to square root the other. However, I can make 25 look different. So 5 to the 3x plus 1 stays the same. But 25, I can rewrite that so that it looks like 5 squared, because that's still 25. And then also up in the power, I had an x minus 4. So those two things get smushed up together. So I'm just taking the 25 and rewriting it. Like it looks a little different, but it's still 25. And now my bases are the same. So we can do just their exponents. So 3x plus 1 equals 2x minus 8. Subtract your x, subtract your 1. And so x is negative 9. So that's where you can maybe get into some sneaky stuff with exponents, which can be really fun. Okay, then, our last property, and this is the one that bugs me so much that I have to teach it to you, just because it's like our calculators should do better than this. So when we start solving next time, there might come a point where I have to take the logarithm of something that I don't know. Like if it's log base 3 of 9, I know what that is. That's 2. But if I have to do log base 3 of 10, I don't know what that is. Like I know it's a little more than 2, but it's a decimal. And so I have to ask my calculator to get that decimal for me. Like somebody way back in the day figured out all those decimals for us. Thank you so much, and stored them into our calculators. However, on a TI, Texas Instrument, trademark, whatever, calculator, there are some logarithmic buttons. We have log, which is just base 10, and we have natural log, which is just base e. So if I'm wanting to do something that is log base 3, I'm kind of screwed, because it doesn't have a log base 3. It doesn't have any other base aside from 10 and e. So that's pretty dumb. In fact, probably your Android, because definitely my iPhone has this capability to change the base. So on my iPhone here, right now, I only see log base 10 and natural log. But if I hit second, I have log base 2. And also right next to that, I have log base y. So again, if I was trying to do log base 3 of 9, which I know is 2, and I needed a base 3, my calculator can do that. So I'd do 9 log, and then I pick my base. So 3 equals, and it tells me 2. Like, your calculator on your phone is much more powerful than a TI, unfortunately. And so also, if I wanted to do that problem where I did 10 log base 3 of 10, so I do 10 log, and then pick my base, and it's a little more than 2, like we expect it to be, okay? But unfortunately, on some standardized tests that you will likely have to take, either SAT, ACT, whatever, you're not allowed to use your iPhone or your Android. You have to use a TI, and they don't have that feature. So I'm going on a little bit of a rant. So we have this last property called change of base, which will allow me to take any log base and change it to a base of 10. So if I had log base b of a, and that base is not 10 or e, and you need to do it on a TI calculator, then the way I change the base is I do log base 10 of a divided by log base 10 of b. So really your base just goes to the bottom and you're dividing. So real quick example of that. If I have log base 5 of 24, again, I always like to kind of pick numbers that we're sort of familiar with, like log base 25, log base 5 of 24, don't know. But log base 5 of 25 is 2. So this should be a little less. And on my TI calculator, I am going to have to type in log base 24. Log base 10 of 24 divided by log base 10 of 5. Okay, so we would do log 24, and we want to end our parenthesis, divided by log of 5, and we're hoping for approximately 2, which we get. And just because I can't stand it, I'm going to do it on my phone as well. It's just like so much faster. It is a little funky, I guess, because we have to type it in backwards. But again, if I hit that second button, my log base, whatever I want it to be, comes up. And so I would do 24 log, and then pick my base, and I get the same thing. And more decimal places. Suck it, TI. Sorry, don't listen to me, TI. You didn't hear anything. So this is approximately 1.9746. And there you go. So this is a necessary evil that we must know how to do, because sometimes when we're solving, we need a different log base, and our calculator can't do it. I'll see you on the next one.